Hi all, welcome to the session and trust you are all doing well, friends. And in this session, we are going to talk about the concept of functions actually. So no matter whether that is a Python programming or C or C++, whichever, in all these aspects, just we are having the concept of the functions everywhere. Okay, we'll try to understand various aspects of the functions. Okay. Now you see here, there are certain aspects where you can study with respect to the functions like user defined, default and flexible arguments in the functions, and thereafter the recursive functions, built-in functions, and most importantly, guys, the lambda functions, where in our Python programming to simplify the logic, okay, just we are having the concept of the lambda functions. Okay, let us jump start. So first, let me give you the brief of what exactly a function, friends. Function allows us to group several statements into a logical block. Assume that I want to perform some kind of the sum, subtract, multiplication, and division. So observe here, rather than providing them as a in a single program, okay, all these particular summation, subtract, multiplication, and division, if I am able to perform these things separately, okay, there is a function summation and there is a function subtract and there is a function multiplication likewise. So accordingly, just we can write down, we can split the appropriate activity rather than following a big program. So majorly guys, several statements into a logical block. I can say this is logical block 1, this is logical block 2, and this is logical block 3. Okay. And in programming, function refers to a named sequence of operations that perform a computation. Most importantly, friends, suppose if I am considering a summation, maybe I'm adding two numbers, and after adding this thing, we should return a value. We should return a value. Just we are performing some logic and we are going to return some sort of the value. And it is used to provide modularity to complex applications and are defined to be reusable or manageable, and which also save the timing. Now observe here guys. So suppose I'm having 100 lines of the code in a single program. Rather I'm having 10 lines each, like some 10 programs. So managing and handling the errors is easy when compared with the larger program. That's what we are saying modularity. Modularization means splitting the appropriate code into the individual modules, and how it is saving the time. Okay, time saving is, friends, like I can reuse the same and I can debug the appropriate code in the fastest manner. And even managing the appropriate code is also, because as we are splitting the code into the multiple partitions, then automatically you can manage these kind of the conventions without any problem. And we communicate with a function through a clearly defined interface, providing certain parameters to the function and receiving some information back. This is pretty simple. Like what we are doing, we are defining a function one and we are sending some argument. And after performing this value, just we are returning some value also finally. So just with the help of the function name, with the help of the argument list, just we are going to return some value. Okay, moving ahead. Now, how we are defining the functions and the types of the functions, because in general, guys, in interviews and in the exams also, who are preparing for the examinations, maybe students or any other members who are preparing for interviews, they generally ask the types of the functions, various kinds of the functions in Python. There are four kinds of the functions available, friends. One is the built-in function, where Python print and input statement, okay, always available without any additional effort on behalf of the programmer. So just every programming language, friends, they're having some basic support of the functionalities, and those functions are by default available. Such kind of the functions are named as the built-in functions. Whereas coming to the second aspect, the user-defined functions. And for the sake of the user, maybe I want to maintain, I want to find out the prime number in the given list, or I want to perform some reverse of the number. So in that particular case, I need to design a logic according to my requirement, and such kind of customized requirements by the user can be implemented with the help of the user defined function. See, write your own function and use them freely in your code. And coming to the lambda function is a small function containing a single expression. This is most commonly used constructs, guys, because we are simplifying the larger code into the smaller ones. And it is pretty much helpful when we must perform a small task with less code. See here, a task with less code is always very helpful to us, and we can make use of that convention. And from Python's pre-installed modules, okay, a lot of functions are available. There is a pre-installed modules like math, okay, or else you can import some of the modules where you can make use of those kind of thing like NumPy we are going to use, pandas I'm going to teach in the course. Okay, within this we are having the notion of the arrays, and as well as the pandas we are having the series and data frame, and along with that we are having some predefined functions. Okay, this is the types of the functions. Now, examples before going to see the hands-on, just will try to understand the examples of the built-in functions, printing, tuple, summation, range, min, max, list, input. Directly you can make use. These are all the built-in functions. User-defined function, friends, as I said, always will start with the definition DEF. Okay, and name of the function, argument 1, argument 2, like that. Okay, so this is the definition. Just by observing this definition, you can see that we are defining a function and there are certain arguments which are related to the function. And coming to the lambda function, which are nothing but arguments or expressions. Just you can make use of the lambda, and here you can specify some sort of the numbers. So some sort of the expressions according to the requirement. We'll see the examples in a detailed way, friend. Just to recollect that lambda functions are smaller. Okay, if I want to reduce the code into a single liner, and then I can make use of the lambda functions. And what do you mean by recursion is repeatedly executing the task. Suppose F1, again, if it is calling F1 function, same function, then we can say that as a recursive call. Okay, here also, as that of the user defined function, just will be having the definition, and accordingly, you can call the same function again and again. Calling the function by itself is known as the recursive function. Coming to the other things, pre-installed modules like math, all these square root finding out, ceiling, floor values, all these kind of the conventions can be observed as a kinds of the functions. Okay, moving ahead. Now, before talking about the user defined functions and all, now let me share the implementation perspective where you can observe the usage. Okay, let me go to the OneNote, Jupyter Notebook. So here we are having certain functionalities here. Let me explain you. As said earlier, just we are making use of the functionalities like I'm making use of the definition. Okay, the function definition and name of the function MSG1 and parameter list. Just we are printing the value. So observe here, guys, while working with any of the function definition, just you need to give the DEF is a keyword along with that name of the function and argument list. Once that is over, just you need to give the colon. OK, so definition, function name, argument list, colon, and whatever the functionality you want to write, you can give here. Especially what I'm doing is just I want to give the printing of the arguments, whatever I have read. Now see how to call the function. Actually, this is known as the calling a function. OK, once the function is defined, just you can make use of that particular function. So with the name of the function MSG1 and whatever the functionality I want to perform, Python functions, just after calling, automatically I'm getting the outcome, whatever the message, because according to the definition of this particular function, what we are doing, just we are printing the data. Now, for example, the second thing also same, like if I want to print the numbers or floating value. So what you need to understand here is, friends, in Python, we are not very particular about the data types. If you observe the message one, here I have given the string. Whereas in the second example, we are giving the integer. Whereas in the third example, we are giving the floating value. So whenever you are working with the functions, automatically just according to your type of the data, this will be taking the dynamic data types and it is going to print. Now moving ahead, just one more example where we are making use of this definition sum. Here two arguments we are taking and we are performing some activity of adding these two arguments and we are printing the corresponding value sum inside the function. So after defining this particular function, what you need to do is just you can call the function sum of and values you can give 10, 20. Automatically what it does is just it is making use of the convention, so obviously it is putting some execution and we are going to get some outcome. So sum inside the function, the value. And similarly, and one more important thing, friends. Okay, generally the important point is while talking about the functions, functions are having the name and they are taking the arguments. And as per norms, friends, every function should return the value because after performing the task, the function should return a value. So the proper way of executing the function is this thing, friends, actually. Like, just only one statement we have changed when compared with this functionality definition to this one. Just we are giving the arguments as usual and we are performing some activity rather than printing. This time what we are doing is just we are returning the value. We are returning the value. Yes. And then just we are storing that value into the total sum equal to 10, 20 and we are printing this value. So now if you want to rather than calling that here directly, I have called that function and I want to pick up that particular information as a return value total and we are printing that. So a small distinction, just we have used the return value. Return statement is nothing but after implementation of the function, just I want to return some value. OK, to the console or to the appropriate command line or whatever the mode. Here we are using the Jupyter notebook so that here only we are printing. Now, similarly, likewise, you can perform any number of functions, friends, user defined functions, maximum value. So again, you can use the if and if else kind of thing or for loops or whatever the orientation. OK, so this is what how you can specify the usage of the functions. Now let us move back to our user defined function definitions. OK, where you can observe in what way we are understanding this. OK, so we have seen some examples. OK, now you can cross check. Just we have given the definition and as well as the function name argument list. Oh, see here, definition function name parameters. Now the definition keyword, this marks the beginning of the function header. Function name is nothing but the unique name that identifies the function. Parameters are arguments where you can pass the arguments here. Values are passed to the function by enclosing them in the parentheses. And of course, whether you may or may not give the arguments, it is purely optional. According to the developer requirement, the parameters can be given or it can be optional also. The colon marks the end of the function header. As we have seen, friends, here definition sum of a comma b, just we are making the colon. OK, end of the function header. And statements, there must be one or more valid statements. Maybe, just we have taken a plus b, some return value like that. OK, one or more statements according to the logic. Notice that the statements are indented. Indentation already we have studied, guys. Like indentation is most important in Python because while using the if or for loop or any other kind of the construct, Python follows some sort of the indentation. The same way, just we have to follow the indentation in terms of the functions also. An optional return statement to return a value from the function. Okay, so but always it is a good programming practice to come up with the return value of the function. So now, as per the analogy, already we have seen you can make use of the parameters, or you can make use of the return value, or you can use the if, for loop, all these kind of the conventions. Okay, so just you follow the according to the examples. Now these are all the examples already we have seen. Okay, so in this example, we are seeing about the maximum. Okay, so if x greater than y in the given arguments, just we are returning the x value. Otherwise, we are returning the y value. And if I'm giving the -3 and -9, -3 is greater than, okay, -9. So we have to return that. If I am giving +3 and +9, obviously 9 is greater than, so 9 should be your answer. Based on the sign, the corresponding function is going to execute. Now, the most commonly used construct is prime number. So prime numbers generally 2, 7, 11, 13, all these kind of things are known as the prime numbers, where that number and 1, okay, only divisible. Okay, that number divisible by these. So now initially what we are taking is we are feeding that number, and then we are equating this n value as 1. Initially count value is 0. What we are trying to do is we are finding out how many values properly divide the corresponding number. Accordingly, the count we are going to increment. Now, until the appropriate number n, one value is there, until it reaches to the number, just every time we are running through the loop. If number percentage n equal to 0, completely if this number is divisible by n, then okay, then only we are incrementing the count. And once that is over, again increment the corresponding value until we reaches to the number. Assume that 7, if I'm feeding as the argument, after completion of 1, 2, 3, 4, 5, 6, and 7. And here friends, 1 and 7 only gives the 0 value. Then finally your count must be 2. Whereas if it is a prime number, for example, if I'm taking 7, then only it is equal to 2. The count value equal to, suppose if I'm giving 6, obviously 1, 2, 3, 6. The count becomes 4 friends actually, because 6 is completely divisible by 1, 2, 3, 6. Okay, the 6 value is giving 0 as the outcome after division. So the count becomes 4. But whereas if I'm talking about 7, it is only 2. So if any time the count value is 2 after dividing that number, then only we are saying that as a prime, otherwise it is a non-prime. So if I'm giving the value 7, just I'm getting the 7 prime. If I'm giving 10, 1 divides, 2 also divides, and 5 also divides, 10 also divides. Here also 4. Count value is 4, so it's not a prime. So purely the logical orientation, friends, how we are making use of this user-defined functions. Okay, and I will be sharing this particular document with you guys. So just to have a look on this and practice. In the next session, just these are also examples, okay, for your practice. I already have explained these things, all these prime, maximum, all these things. And then we are talking about one more important topic in terms of the functions, that is the scope and lifetime of the variables. Okay, thank you.